All right, so please take a look at question 24. We have a spring is modeling a sinusoidal. Sinusoidal is just referring to either sine or cosine. That rests 2.5 centimeter above the ground. If the mass on the spring is pulled 2 cm below its resting position and then released, it requires 0.5 seconds to move to the maximum position. Okay, I think there's a typo here. To move the, okay, it requires 0.5 seconds to move from, okay, missing one word. From the maximum position to its minimum position. And we ignore the friction and air resistance, which means it will just keep on going up and down, right? Goes to the minimum, go to maximum, and continue. Part A, write a sine function. So this time we just do sine, okay? Without reflection. That describes the motion of the mass from its releasing position. And then once you got the function we will use it to answer part B. Okay, what height is the mass 4.3 seconds later? Okay. All right, so we'll draw the picture first, right? This is a spring. Okay, how do we draw a spring? How does spring look like? Nick, how do you draw a spring if I ask you to draw it? What would you do?
It's like a spiral.
Spiral, okay, can you show me on the screen?
Okay, I'll try.
Yeah.
So it's that.
Oh, very good. Yeah, okay. And then we're gonna hang a little mass there, right? Okay, so let me put that away first. Okay, so draw a spiral thing here, right? Okay, and then we need to hang something, right? So let's hang a little weight with a happy face. Okay, so this is a resting position, right? Resting means you just put it there. There's no external force, okay? Just resting. And there's a ground, right? We need to draw the ground. Okay. So right now it's resting 2.5 centimeter, right? Rest 2.5 cm above the ground. Okay, so here to here, 2.5 cm. If the mass on the spring is pulled 2 cm below its resting position, so I want to pull this weight down by 2 centimeters, right? 2 cm below the resting. So the spring will be stretched, right? Stretched. Okay, so it'll be hanging here. Okay, being pulled down, and it's pulled down by 2 centimeters. So it's talking about this part, that's 2. Okay, we'll pull it down by 2 cm. And then we let it pass, let it go, right? Release it. So the spring will pull it up and even pull it closer, right? It'll be squeezed, okay? And then we assume that there's no friction air resistance to change the height, okay, the amplitude. So continue to go to 2 above. Okay, and then we'll go down again, go down to 2 below, and then go up to 2 above the resting position. So the resting is like the middle line, right? Where it's not moving. So continue bouncing like this forever. All right. So we can draw the axis like that. So this is the horizontal is the T, like before the time, right? And H is the height above the ground. All right, so you will need to have 4 numbers, right? 4 important numbers. Highest, right? Very important. Lowest, get the middle number, right? And then we also need a period, okay? These are the 4 important things to make a complete graph. Once you figure those out, then you can draw the sketch, okay? So I'll let you try that by yourself this time. Find all the 4 important numbers. Okay, once you got those 4 numbers, you can raise your hand and then we'll check, right? Please find the highest, lowest, middle number, and the period. After you've done that, please put it on the axis, okay? And then raise your hand. Okay, should be done by now. Okay, it's not complicated. Okay, look at the graph, get the 4 numbers. Okay, Chris, what's the maximum number?
Is it 4.5?
4.5 above the ground, right?
Yes.
Yeah, very good. Okay, because resting is at 2.5, it pushes up, pulled up by 2, another 2, right? 4.5. centimeter. Okay, minimum, what's the minimum height of this weight? Sophie?
Sorry, you were lagging. Could you repeat the question again?
What's the minimum height of this mass?
0.5 centimeters above
Yeah,
the
very
ground.
good. Yeah. So lowest place. So remember, lowest place is not 2, okay? Lowest place is talking about above the ground, okay? All the measurements are from the ground. Right, now we need a middle, right? Susan, what's the middle number?
2.5.
2.5, very good. How did you find that? Can you tell us?
I added 0.5 to 4.5 divided by 2.
Very good. Yeah, okay, so we get the average. Okay, 4.5 maximum plus minimum, we divided by 2. Okay, so it's different from amplitude. Okay, average is finding the middle number, 2.5. Okay, we need to know the period. Anyone got the period? Period means the time, right? How long it takes for one complete trip, right? From lowest to highest back down, or highest to lowest back up, right? A complete circle, round trip. Okay, if you have the period, please raise your hand. How much time does it take for this little head to go round trip? Only one person has it? What's the period? Okay, Marcus, do you know how long the period is?
Not yet.
Okay. Do you know what it has to do with? Which number does it have to do with?
Isn't it the one on the T? Like,
Yeah, has to be on the T, the time, right? So does it mention anything about the time in the question?
0.5 seconds.
Okay. So would that be the period?
Uh, I think.
Period means it needs to make a round trip, right?
Yeah.
What's the 0.5 seconds? It goes from,
To move from the maximum to the minimum.
so is that a round trip?
No.
So what do you need to do?
Find like how long it take for a round trip.
Yeah, so how do I use that to get a round trip then?
I don't know.
From highest, okay, let's draw it out. Okay, highest is here, goes down, that's the lowest, right?
Yeah.
How long does it take?
Half a second.
Half a second, right? Now if you want to make a round trip, it has to go back up and
So
back
a
up.
second.
So the whole round trip will be,
Is it a second?
yeah, 1 second. Okay, so maximum to minimum, that's half the trip, one way, right? You have to come back, then it takes another half a second. Okay, so it takes a full 1 second to complete one cycle. You can put 1 second here, right? 0.5 second. It's halfway, right? Maximum to minimum, okay? All right, so where should we put the starting point? Okay, because before, right, for the previous question, we put the starting point at the highest because it tells you that a pedal starts at the highest point, right? Starts at the highest point. You can either start, you can start at the highest, you can start at the middle, start at the lowest, right? But for this question, where does the question want you to start at? Philip, where do you think we should start the point?
The middle, 2.5,
How do you know? Does it tell you?
because it's the resting position. It's
Does it
between
tell
the
you
highest
where-
and the lowest.
Does it tell you where it, does it tell you to start at the resting position?
Yeah, because it's resting at the start. It rests 2.5 cm above the ground.
Okay, can you read question A?
Oh, this one. Write a sine function that describes the motion of the mass from its releasing position.
Yeah, okay, so it wants you to start at the releasing position. Where is that?
Bottom.
Yeah, the bottom part, okay? Because the function we want to write, right, is starting from the releasing position. So usually they will tell you, okay, to where you want the graph to start at. If it doesn't tell you, then you can choose, okay? So make sure you have to pay attention to all the little details. So this means you want to start at minimum, okay? Because you start by pulling it down and then let it go, right? So you start bouncing. So starts at the minimum place and then go up, right? So that's half the trip, right? Go down. Okay, do not draw a triangle, right? Open up, open down, open up, open down now, and then open up. Okay, so if you wants to continue the second round, we'll go like that again, right? 2 cycles. Okay, so it takes another second to do another cycle. So that's the graph, okay? Once you get to here, everything else the same as before. So now I'll let you carry on the rest, okay? Please write a sine function, okay? Sine function without reflection, okay? If it did not tell you to use reflection, don't use it. Keep it simple. Right, once you got a sine function, please raise your hand. And remember the variable is not X and Y, okay? It's T and H. So your answer should be H equals something, all right? So I'll give you about 5 minutes, okay, to finish A. Shouldn't take that long, okay? Okay, very good. We have 8 people already got the answer. And remember to choose the y-axis, so it's the closest to the original. Okay, I will draw the midline. Oh, okay. Jenny asked, what is sinusoidal function? Sinusoidal is just referring to either a sine function or a cosine function. Okay, it's a wave function. Right, so the midline should go through 2.5, right? Okay, if you're done, please raise your hand. Okay, Sophie, what's your answer? H equals? I cannot hear you. Your mic is not working, is it? Did you turn it on? Sophie? Oh, out of battery. Okay. Can you type it out then? Okay, so 2 sine. Okay, let me write it down. So remember, it's using t and h. Okay, 2 sine, and then 2 pi over 1.25, and then t minus 0.75, and then plus 2.5. Okay. Anyone else has different? Okay. Thank you. Thank you, Sophie. Wellen, do you have the same or anything different?
One sec, I'm looking.
Hmm?
Oh, one sec.
Okay.
I got the same.
Everything the same?
Wait, no.
All the A, B, C, D?
Oh, one sec, let me see.
Okay.
Isn't A 2.5?
A is 2.5.
Yeah.
And then sine. How about the other one?
One sec. C is supposed to be 0.25. So it'd be like minus 0.25.
So T minus 0.25.
Yeah.
Okay, what about B?
Uh, one sec, let me check that.
Okay.
I'm pretty sure I got 2 pi for period.
So just 2 pi.
2 pi, yeah.
Okay, what about D?
Same, 2.5.
Plus 2.5. Okay, yep. Right, so let's get another one. Kellen, what's yours? What do you think? We have two answers here.
Oh, I have h is equal to 2 sine bracket 2 pi over 1.25 bracket t minus 0.75 bracket plus 2.5.
Well, okay, so same as the first answer then.
Yeah.
Okay. Okay, so anyone got the second answer or something different? Anyone got something different than these two? Same as second. Okay, so we have 2 votes for each one. It's a tie. Angela, what do you think?
I got the same as the second one.
Okay, A, B, C, D all the same?
Yeah.
Yeah, okay. Oh, wait. Okay, Jenny says hers is different. Okay, which part? So do you want to share? What's yours? Okay. 2 sine 2 pi t minus 0.25 plus 2.5. Okay, so kind of a combination of those two, right? Anyone else want to share your answers? Anything different? Eric?
I got the same as the last one, except I don't have 2 pi. It's just t minus 0.25.
So h equal to 2 sine and then t minus 0.25.
It's h equals 2.5 sine.
Oh,
And then
2.5
the rest
sine.
are the same. Yeah.
Oh, okay, like that?
Yeah.
Okay, I think it's yeah, so we got all the possible numbers, right? 2, 2.5, 1.25, right? All the common ones. So we all agree on D then. Okay, D should be correct. All right, let's start with A. But we should draw the axis, right? Y-axis should be all on the same place. Otherwise, your CD will be wrong. We want a sine function. Sine will start by going up, down, down, up. Okay? Sine, if there's no reflection, it should go up, down, down, up. That's a sine without reflection. So our starting y-axis should be here then. Okay, and then this will be your new origin. So that new origin should be at, because you know, you see the middle part 0.5, that means here will be 0.25, 0.75, okay? So we would have 0.25 and 2.5. So our new origin, which is our CD, should be 0.25, 2.5. Okay, let's take these to the side first. All right, and then next thing we need to get is the amplitude, right? We can just use the formula. Amplitude is maximum minus minimum divided by 2. Right? Follow the formula. So 4.5 minus 0.5 is 4. 4 divided by 2 should be 2. So that's our A. Okay. B is 2 pi divided by the period. So period, you can look at the yellow part, right? The whole thing starting from 0.25 and then finishes at here. This should be at 1.25. Right? That's your one period. Or you can start from lowest to lowest. Right? You can either go from lowest to lowest or highest to highest. Okay, that also is a period. Okay, but either way, the period should be 1. Okay, so 2 pi over 1 should be 2 pi. So there's your A, B, C, D. Okay, so we have H should equal to A sine B is 2 pi. Okay, so we need a 2 pi there. T minus 0.25. That's our C, right? And then plus 2.5. Okay, I guess we have an answer. All right, very good. So answer should be this one. Okay, good job. Okay, good job for everyone who tried. Okay, pretty close. Okay, just missing 1 or 2. But I would like to know though, if you got the 1.25, can you tell me how you got the 1.25 before? Who had the 1.25 for the B? 2 pi over 1.25. I forgot who said that answer. Who had this one? The 2 pi over 1.25. Was it you, Sophie? Did you say that one? Oh yeah, okay. Yeah, okay, miscounted the period. Right, okay. Yeah, so you will need the size of space to get a period, right? So now we found the function for sine, right? For this part A. Okay, then this will help us find the height at any time, okay, after you release. So we can make a prediction first. It's asking what is the height? Okay, we're doing question B now. What is the height 4.3 seconds after being released? So based on this graph, because every 1 second it will repeat, right? So you can, let me highlight it, all right? So every time after 1 second, it will be the same thing happening. Okay, let me erase all the unnecessary things here, okay? Let's erase those lines. Okay, so what you can do, right, to predict your answer, this is 1 second, right? 1 period. Okay, and then 2 seconds, same thing, right? It will repeat again, right? And then it will do the same thing. 3 seconds, right? And then repeat again. 4 seconds, right? And then 4.3. So 0.3 seconds will be reaching about here, right? 4 seconds and then 0.3 second. 0.3 is around this place, 0.3. So we are guessing the height should be somewhere between 2.5 to 4.5. So probably about 3, right? Around 3. That's our guessing. Okay, so you need to know what we are doing. So when you get an answer, right? It's not just plugging into the calculator. When you get the answer, you have to double check, does the answer make sense, right? So I'm guessing that it should be around 3 centimeters, 3 point something, okay, for this place. All right, so let's try it out, right? So at t equals to 4.3 seconds. So plug it in, okay? This is a function. So you can write it as a function symbol. H of 4.3, that's okay. All right, so you'll need a calculator, all right? So everyone please take out your calculator. 2 sine. You need to have it in the radian mode, okay? There's no degree here. And then 4.3 minus 0.25. Make sure you type it in correctly. Okay, the answer that comes out should be around 3, all right? Somewhere about 3, maybe 2.9, maybe 3 point something. Okay, between 2.5 to 4.5. Okay, so if you have an answer, please raise your hand. Let's round to 2 decimal places, okay? So everyone, please try it with a calculator. Make sure you're in radian mode. And be careful with the brackets, okay? Brackets means everything here in the red bracket should be inside a sign, okay? Okay, please raise your hand if you have a number. Okay, Evan, what's your answer? Hmm? 3.36. Okay, anyone else? Daniel, what's your answer?
3.118.
3.118. So if you round it, 3.12. Right. Nick, what about you?
I got the same thing.
Yeah, okay. Yeah, Jenny also has the same. Okay, so it should be 3.12. Evan, you want to try again? Does your calculator show what you typed in? Yeah, so make sure you type everything in, all together, right? Type exactly what you see. You should have 2 double brackets. Okay. Okay. All right, so answer should be 3.12. Okay, and the unit, this one is centimeter. All right, so you can use this to find what they want you to find. Okay, the next one, we are just gonna go over the graph because you will get Ferries wheel for homework as well. Okay, we'll go over the picture, right? So for this one, we have a Ferris wheel with a radius of 30 centimeter, right? That's important, Ferris wheel. And that Ferris wheel is placed 2 meters above the ground and varies sinusoidally with the time. Okay, so you see the time, right? Got to do with the height and time. It makes one rotation every 40 seconds. One rotation means one period, right? That's important. The person is sitting 32 meters from the ground and rising, right? When it starts to rotate, okay? So it tells you where the starting place is. So please draw a picture, okay, by yourself. Draw one period, okay? And then see if you have the same picture as me, right? You need to have a ground, Ferris wheel, right? Ferris wheel. Right, and then we have seats, little carts. Okay, and then we'll start turning. Highest, middle, lowest, one period. Okay, so fill those out, plot the point, okay, make the curve. Once you got a curve, you can raise your hand, okay? We'll go over the graph. Well, Evan? Evan, are you there? Evan? Can you turn on your mic? Evan? Okay, if you finish the graph, please raise your hand. Radius of 30, okay? Radius means this thing is 30, okay? 30 everywhere. Two meters above the ground, so that's referring to this part. Okay, the Ferris wheel is being placed because you cannot put the Ferris wheel on the ground, right? It will roll away. It will become roller coaster then. Okay, Evan, are you there?
Oh, yeah.
Yeah, okay. For your homework, I was looking at your homework. You did the wrong question. For the bottom two question, the part one is you did the top part. It's the bottom part. The top part is, yeah, those number 3 and 4. It's not those two questions.
Oh, okay, let me redo it then.
Yeah, it's these ones. Let me show you. This one. Part 1 is referring to this. Number 3, okay? And then the next page, number 4.
Ah, okay, thank you.
Yeah,
Let me
they
just
give
redo
you
it
the,
then.
yeah, the graph, and then you need to get the function, okay? All right, so we have 3 people got the graph, okay? Please raise your hand if you are done the graph. Okay, we'll check the numbers first, okay? Highest number, because radius is 30, okay? So that means that the highest place should be 60 in the diameter plus the 2 meter, should be 62. Lowest is at 2, right? So you have a whole diameter. Diameter is 60. Make sense? And radius of 30, so that means 30 to each end. So this should be at 32. All right, period, it tells you it makes one turn in 40 seconds. So period is 40 seconds. And the person is sitting at 32 from the ground, right? So that means the person is here. Okay, sitting there, and then it goes up, starts by rising. Okay, so your starting point should be here, divided into 4 equal parts, right? Because the size of space is 4 equal parts, and then complete the graph. Okay, so that's what you need to do for each word problem. Okay, make sure you have the right numbers, highest, lowest, middle, and a period. After that, get a sketch, right? Make sure you are starting at the right place. Okay, please raise your hand if you finish the graph. Starts from 32 and rising, okay? Rising means next point should go up. Okay, are we done the graph? Please raise your hand. Okay, after going to the maximum, we'll go down and go down to the minimum, right? And go back to the middle. So your curve will look like this: open down, open up. Okay, each size of space is 10, so 10, 20, 30, and 40. Okay, so after that, you just get a function. Okay, so now I would like to talk about one question in the homework, okay, so you don't get confused. All right, so please turn to, where is it? Page, this one. Page 65. Okay, can you raise your hand if you're on page 65? Angela, Chris, Eric, Joseph, and Marcus. Okay, we're on page 65. Okay, so look at question 5. This one, it tells you the function, right? H of t equal to something, something, right? Function, so it tells you the function already. It tells you the function for the depth of the water, H meter, right? At different time, during different time of the day, okay? So it's asking what is the depth? Just like asking what is the height at different time. So the time they are in terms of the clock, right? 3 a.m., 9:30 a.m., 1 p.m., right? But you cannot just plug those numbers in. You need to change those time into hours. Hours. Okay? So it starts from midnight. Midnight will be like counted as 0 hours. So for example, like 3 a.m., then your T will be like 3. Okay? 9:30 is like 9 hours and 30 minutes, right? But it's a mix of hour and minutes. So you need to change this into hours. So 30 minutes is like half an hour, right? So you should use 9.5 to plug in, okay? To find the height. We're looking for the depth, okay? Not the height, okay? You need to plug it in. And like this one, right? This one, 1 p.m. What will be the hour for 1 p.m.? Eric?
Would it be 13?
Yeah, then you should use 13, okay? So please do not plug in 1, okay? So same with this one. You think about what this one will be, okay? 10:45 p.m., okay? One number to plug in. Yeah, so other than that, it's kind of like the question we did before. They give you a story, okay? You need to write out a function and then use it to answer a few questions. Okay, so yeah, so if you don't have questions, I'll see you next week. Okay, otherwise, please stay after class. And yeah, so Evan and Marcus, please stay after. Okay.
Well, I handed mine in just now.
Oh, okay. Right, then you are good then.
Okay.
Okay. Bye-bye, everyone.
Bye, Jason.
Bye.
Bye, Jason. Thank you.
Yeah, you're welcome.
Jason,
Yes.
could you explain how you draw the graphs?
Yeah, which one?
Because I get like the numbers and stuff, but I don't get how you can connect the dots like that, I guess.
The Ferris wheel, this one?
Just in general.
Oh, in general, okay.
You know where to start and which way the graph goes.
Okay, well, do you get how I connect the points for this one, Ferris wheel?
No.
Okay, and then I'll erase the points first, okay? But you understand how we get all the numbers, right?
Yeah.
Okay, so I know the first point has to start from 32 is because from the question, it tells you the person is sitting at 32 meter from the ground.
Okay.
So that's why, and then after that, it starts to rotate and
Mhm.
rising means go up,
Uh-huh.
right? So your starting point, you have to start at 32 because that's what the question tell you to start.
Okay.
So you won't start at 2, you won't start at 62, right?
Uh-huh.
Okay, and then after that, it tells you it has to go by rising, right? So it cannot put it down here. You have to make it go up. So the only way to go up is to put it at 62.
Okay.
Make sense?
Uh-huh.
Okay, and then once you get to 62, it cannot go up anymore, right? Because that's the end of the Ferris wheel. So you
Yeah.
go down, right? And then comes back down, goes back up. Make sense?
Yes.
Right? And then do you know how to connect them?
Yeah, I know how to connect them.
Yeah, okay, so connecting is okay.
Could
So-
you explain one of the questions we did previously then?
Yeah, of course. Okay. So for example, like 24, right? 24, I also started with the, for this one, I started with the lowest point at 0.5.
Mm-hmm.
Okay, because in the question, it tells you that write a sine function, right? Sine function that describe the motion of the mass from, right? From the releasing position. Releasing means where you let the mass to go, right?
Mm-hmm.
So because the story tells you to pull it down and then released, right? You pull 2 centimeters below first and then release. So your releasing position is this place. You see the
Oh, yeah.
happy face, right?
Mm-hmm.
Yeah, so that's why my first point is over there.
Okay.
Make sense? So you get
Yes.
all those from the sentences.
Okay.
Yeah, and then after releasing, there's no way to go down, right? So it has to go up, go up, go down, go down. Make sense?
Yes.
Yeah, okay. So next time you could ask in class, okay? It might help other people too, okay?
Okay, but I'm scared to ask in class.
No, don't be scared. You can type it out, right?
Okay.
And then I can explain because sometimes your question will be other people, and then other people may be scared to ask too, right? So if you ask, you are helping others too. Okay.
Thank you.
And what about 23? You okay with 23?
23, could you explain? Is it because it says it starts at the highest point?
Let me see. Yeah, pedal starts at the highest point. So I start at 30.
Yeah, okay.
Okay.
Yes.
All right, good.
Okay, thank you, Jason.
You're welcome. See you.
See you.
Jason, can I ask a question?
Yeah.
It's it's about the period. Am I supposed to do like what am I supposed to do? 64 part 1, right?
Which the
You
homework?
said I did one
Yeah,
question wrong.
Yeah, the bottom part, right?
Oh, it's this one. Okay.
Yeah.
I was confused on how to find the to tell the let's go to find the new origin.
Yeah, so if it's a cosine, right? Because question 3 has part A and part B. Okay. So
Okay.
for part A, it wants you to get a cosine. So you need to know what cosine looks like. Cosine starts from where?
Let me check.
Does it start from maximum or minimum or middle?
I think it's maximum.
Yeah, start from maximum. Start from highest and then go down, go down, go up, right?
Yeah.
Yeah, so we want to search for that on the graph. So the part where it looks like that, it will be over here. Go down, go down, go up, go up. Make sense?
Yeah.
Right? So that tells you that your y-axis will be this place. So your origin will be here.
Okay.
Does that make sense?
Yes.
Okay, you want to find the starting place so it looks like what you're looking for. You're looking for cosine, so you have to start there.
Yeah.
Okay, if you are looking for sine instead, right? Now erase that. If it's looking for sine, where does the sine start? Sine graph.
Isn't it the same? Maximum?
No, cosine start from maximum, but sine doesn't start from maximum.
Oh, the middle.
Yeah, from middle and then goes which way?
Up and then down.
Yeah,
towards the-
up, down, down, up, right?
Yeah.
Yeah, okay, so the part of the graph that looks like that will be this section. Make sense?
Yeah. Okay.
So your axis, you will need to put it here to be your new origin.
Okay.
Okay, so if it's
Yeah.
cosine, different place, sine will be different place. Okay,
Okay. Thank you. Also, I have one more question. For
yeah,
the is this period for under the graph? It says period equals pi over 6 times 8. How did you get? Where did the 8 come from?
the 8 because that person counted the boxes. Period means complete one cycle, right?
Yeah.
If you look at the yellow highlighted part, if you count the spaces from the beginning, okay, give me 1 second. Yeah, so that's 1, 2, 3, 4, 5. Oh, okay, disappear. 2, 3, 4, 5, 6, 7, 8. That's why it's 8.
Okay.
It takes 8 boxes to complete one cycle, right? To
Okay.
complete the whole picture. And each box is pi over 6. So that's why you times it by 8.
Okay. Okay.
Okay.
Thank you.
Yeah.
And just to clarify, to find the amp is just you do 12 plus 6 and then you divide by 2, right?
The amplitude? No,
Yeah.
no. Amplitude is you need to minus 12 minus the lowest. Lowest is at 4.
Oh, okay.
You see on the screen, I showed it here.
Oh, yeah.
Yeah, okay. The adding together, that's for finding average.
Oh, okay.
Okay.
Okay. All right. Thank you.
Yeah, you're welcome. Hi, Shanier. Hello, Shanier. Shanier, why are you here? How are you? Shanier, do you have questions? Okay, yeah, you can ask me now. Does your mic work? Okay.